Hello, this is Mr. Stansbury. I'm going to take you through the notes on financial mathematics. Okay. At the end of this, you should be able to say I can use the compound interest formula to calculate principal, interest rate, amount of interest, length of loan, and or effective rate of a loan. All right, so first things first, compound interest formula. This is the formula that you will get on your IB test. It's the FV, stands for future value, which is the newer value. Equals PV, present value, or the older value. 1 plus R is the interest rate, and that's not as a decimal, just the plain interest rate, because dividing by 100 here is going to turn that into the decimal. And then K is the compounding periods per year, and N is for the number of years. So that's our formula, okay? Okay, example 12, $22,000 is invested for 8 years at 3.1% PA. That stands for per annum, or annually, annual interest compounded annually. So what will it amount to at the end of this period? So let's see, for A here, we're going to just use our formula here, right? So we want to know what the future value is, so we're going to solve for FV. The present value, the original amount, is 22,000. And then we'll do 1 plus our rate here is 3.1. Divide that by 100, and that's going to turn into the decimal. And then also multiplied by the number of compound interest periods per year. So since it's compounded annually, that means that this is just a 1. And so that means this other K is also just a 1. And then we want to know for, this is at 8 years times 8. Okay, so we can just plug this into the calculator. Let's simplify it first to make it a little bit easier for us. 22,000, 1. So 3.1 divided by 100 is 0.031, right? Because we just move the decimal over 2 spots. And then 1 times 8 is 8. So we can just put that right into our calculator. 22,000, and then times 1 plus 0.031 is 1.031 to the 8th power, so for 8 years. So it's going to end up being worth 28,086 and 14 cents. Right, so that is the future value. If it's compound, the interest is compounded annually. Okay, how much interest has been earned? So if you started with 22, you ended with 28. To find the interest earned, we're simply going to take 28,086.14 and subtract the initial 22,000 that was invested, and that's going to leave us with 0.86, and that's going to leave us with $6,086.14 is going to be how much interest has been earned. Okay? All right. Example 13. $7,500 is invested for 5 years at 3.5% per annum interest compounded quarterly. So that's going to change. That's where the K comes into play there. Find the value of the investment at the end of this period. So future value is going to equal the initial value, which is 7,500 times 1 plus the percentage rate, which is 3.5 divided by 100 times the K, again, which is how often it's compounded per year. So if it's quarterly, that means it's 4 times a year. So we'll do a 4. Those numbers are always going to match because those are both Ks. And then this is for 5 years. So let's simplify this first so we can make it look a little nicer. So we got 3.5 divided by 100 times 4 is 400. Right, so that's 0.00875. 1 plus 0.00875. All to the 4 times 5 is 20. 7,500. And that is our future value, right? So back to our calculator, we can just enter this all in. That number's not too bad. So 7,500 times 1 point, because we're just adding those together, 1.00875 all to the 20th power. And that gives us 892755. So the future value is going to equal 892755. Okay, find the value of the investment at the end of this period. Okay, so that's what we have. All right, let's take a look at another example. But first, let's have a little comedy break. All right. Let's see. Let's take a look. Example 14. How much does Lionel need to invest now to get a maturing value of $17,000 in 3 years' time, given interest is 5.2% compounded monthly? So now this $17,000, this $17,000 here is going to go into the future value, and we got to figure out what the present value is. So we get $17,000 because we want to end up with $17,000. We want to know how much we need to invest now. Okay, 1 plus our rate is 5.2 over 100 times. Now compounded monthly is monthly. There's 12 months in a year, so that's going to be a 12. This is going to be a 12, and after 3 years' time. So 17,000 is going to equal PV times, let's see, let's calculate what that is. So we got 5.2 divided by 100 times 12 is 1,200. Gives us that. So it's 1.00433. So this is going to be 1.00433. As many threes as we can muster in there, all to the 36th power. All right, so let's do this. We just want to figure out what this to the 36th power is, right? That's going to give us some value. So let's take that answer, add 1 to it. There's our 1.04333. And then let's take that now to the 36th power. Oops, not to the 6th, but the 36th. There we go. And we get 1.1684. What was it? 1.1684. And there's a 3 in there. Equal, that's the present value, times that equals 17,000. To figure out the present value, we just need to get rid of this 1.16843, right? So divide 17,000 by 1.16843, and that tells us that we would need to invest back originally. So I'm not going to clear that out because I want to take 17,000 and divide it by my answer. Second answer. Then I don't have to re-enter all that in, and it's not rounded off nearly as bad. So 14,549.41. Okay, so we got to invest about 14,550 bucks or so to get 17,000 in 3 years. Okay? All right.